Hello. Today we're going to be working on the review sheet for not the review sheet, I'm sorry. Today we're going to be working on the second day of real life trig graphs. Now, I'm going to work on the even and I'm going to ask you to do the odd ones without me. So here we have our first problem. The populations of certain species of fish in a river, as shown in the accompanying diagram over a 12-month interval, can be modeled by the equation y equals a cosine bx plus d. Now, the thing I need you to notice is that you have the a for amplitude, and we have the b, which is for the frequency, and then we have the d, which would be our midline shift. Now, if we need to write about this, the first thing I'm going to look to see if I can find is the amplitude. Now, this is not oscillating up and down over the zero. If we look, we have a range that is going from 2,000 to 6,000. And if my range is going from 2,000 to 6,000, I would find my amplitude by taking the 6,000 and I would minus the 2,000, and that would give me a range of 4,000. And then if I divide that in half, that now is going to give me an amplitude that equals 2,000. Now, if I'm oscillating up and down 2,000 from the midline, the next thing the range tells me is the midline, because now I am going to take the 6,000 and I'm going to add it to the 2,000. And then I'm going to divide that by 2. And this gives me a midline that equals 4,000. So if I take a look at the 4,000, I'm going to use the yellow. If this is my midline, whoa. Now, let's see what happens. From this midline, if I go up 2,000, I hit 6,000. And from this midline, if I go down 2,000, I hit. So therefore, 4,000 is the correct midline. And my amplitude is 2,000 because, again, from the middle, I go up 2,000 or I go down 2,000. So I now found my A and I found my D. But what about the frequency? Well, the frequency, I'm going to use the highlighter for a moment. The frequency, if you recall, is the amount of time it takes for one full rotation. This is cosine. One full rotation of cosine is you start high, you go down in the middle to your lowest point, and then you go back to the highest point. That tells me that it took 6 months for a full rotation. And at 12 months, I now have 2 full rotations. But this now is giving me my period. I don't want that one. All right. This now is giving me from here to here. This is where I have my full rotation. So this here is my period is 6 months. Now, if my period equals 6, I need to also recall that the formula for period comes from 2 pi divided by the frequency. So here's my 2 pi, And if I divide this by the frequency, which is b, I already know my period now is 6. So 6 is equal to 2 pi divided by the b, because I don't know what the b is yet. And if I'm dividing by b and I want to get rid of that, of course we know we multiply both sides by b. So now I have 6b is equal to 2 pi. Divide both sides by 6, and I find that my b is equal to pi divided by 3. So my frequency now is pi divided by 3. So if I now wanted to write my full answer according to what they gave me here, this would now be y is equal to my amplitude of 2000 cosine of my frequency, which is pi divided by 3, times the time. They told me to use x. Make sure you close the parenthesis, because now at the end is the midline, which is 4,000. But we need to make sure that we don't put that 4,000 in the parenthesis with the x. The midline is outside, and there is number 2. Now, if we go to problem number 4, notice on number 4, I put the table for you already, and I'm going to explain to you why I did that. If we look at this problem, it's talking about a building's temperature. So again, a real life graph over the course of a day. Now, the formula is 8 cosine of the time plus 78. What that's telling me is that my amplitude is 8. And my amplitude is going to oscillate 8, down 8, and above 8 to the midline, which is 78. So if my amplitude is going up and down 8 and my midline is 78, my range of my values is 70 to 86. So if you take a look, they gave us a graph that's mostly labeled. I took the liberty of putting in the 65, 75, and 85. Now, this one is a little different from some of our other videos. The frequency on this is 1. So when you take a look, we have a frequency of 1. And when our frequency was a rational number, we normally had radian measure on the x-axis. But again, we're in the real world, and so that's just not the way it's going to work. Not only that, they told us the domain has to go from 6 to 17. So again, notice the graph that they gave you was labeled. So this is telling me that I am absolutely going to need my calculator, and I am going to need to do a couple of things on this calculator. The first thing I'm going to need to do is make sure that I am in radian mode. So first, I'm in radian mode. Second, I have to set my window. Now, my window has to match my graph. The x's are going from 6 to 17. So I'm going to count by ones. So this is going to give me the graph that will match this one. I need the radian so that cosine curve will actually show up. Now, the y, I'm going, according to this, from 60 degrees up to 90 degrees, and I counted by 5s. So resetting your window to match the graph that you're making is very, very important. So if I go into y equal and I clear out anything that's been left there from before, let's put in the 8 cosine of time, but I got to use the x. And again, the midline has to be at the back. And if I hit graph, this is what I get. And this is exactly what's going to happen on my picture when I plot my points. Now again, because we're talking about hours of the day, we're going to use our table to help us out. So at hour 6, this rounds to 86. Notice I rounded on my table. And that again goes with, just for a moment, I'll get rid of the calculator, that goes with my range. My highest point on my range was 86. So if I were to take my table and I were to plot my points, at 6, I am up here at 86. So 6, I am up here at 86. And notice between 8 and 9, I'm at my lowest point is 70. So somewhere between 8 and 9, I am at my lowest point is 70. And then I am up at 86 between 12 and 13. And then I am down at my low point at 16. And at 17, I'm heading on back up. So if I try to make this graph as neatly as I can with the mouse, we are going to see, again, you have to have curves. And for some people where I wrote you notes, you can't give me points. Whoa, that was really, really bad. Let me see if I could just fix that. You can't give me points and you can't give me straight lines. There has to be curves going on. All right, so this one's a little bit better than the first one. All right, so let me now get rid of the first graph. Okay, so then the next thing we want to just double check, if I take a look at where my midline of 78 was, is this actually looking like the middle is going through about 78? And yeah, it really does. That really kind of looks like that would be the middle. Cosine starts high and cosine ends high. So here's the full cosine curve and then a piece of another cosine curve. The next thing they want to know is the temperature has to be above 80 degrees for the air conditioning to run. So here's my 80 degrees. Now, back when we did this, even when we were in the exponent unit, we would have to go to y2, and we would have to put in that 80 degrees. That's the parameter of our problem. That's what we're looking to find. So here now, we know that this part here was 6. But now we have to find this here because underneath here was where the air conditioning was running. And the air conditioner is running here. So if I use the intersect key, second, calculate number 5, let's find this first intersection right here. You hit enter 3 times. And 7.6, so this is our 7.6. So right now, if the air conditioner was running from hour 6 to 7.6, it was running for 1.6 hours. Now we have to go back to the calculator and we have to use the intersect key. All right, let's do that again. Second, calculate 5. All right, now let's find these 2 intersection pieces. So here is 11.2 hours. And let's find the other one. Now we got to move to the final point. enter 3 times. And this is 13.9. So this one here now is 13.9. So 13.9 minus 11.2, this is now running for 2.7 hours. That means overall in this building, this air conditioner ran for a total of 4.3 hours. Now, one of the things I've been writing to a lot of people is that I haven't been seeing a whole lot of labels. Now, I have my amplitude, I have my midline, I have my range. And one of the things that I need to make sure is that I also have the frequency and the period. So the frequency, again, was 1. I highlighted it, but here it is. I wrote it out. And the period is going to be 2 pi. Now, again, this is the real world, so they had us labeled with numbers. And this is why you would want to be able to use the calculator so that you can get yourself through all these different problems. The next problem, problem number 6. Now, problem number 6 has 2 impulses on the same screen, and they're telling us now this is the domain, 0 to 360. Now, that's how I'm going to label. Instead of pi over 2, I have 90. Instead of pi, I have 180. 3 pi over 2 for 270. And then here's my 2 pi, 360. They told me this time to make sure I use the numbers. Now, the next thing is on the paper, I want you to cross this off. I never taught you an algebraic solution. We're going to use the graphic solution. We're going to cross that off right now. Now, notice too that before I went to this page, I took this one and I labeled the amplitude of 2, frequency of 1, and the period of 2 pi, and then there's the range. So if I were to continue with blue, let me just make my points. This would now have sine starts at 0. At 90 degrees, sine is at its maximum. 180, it's at 0. 270 is at its minimum, and then 360. So if I try to draw this as neatly as I can, here is my blue sine curve. Next, we have our pink, the 1 plus sine of x. Now, let me just go through a little bit of this, if I can. This one is saying that I have a midline of 1. They started with the midline. I have an amplitude of 1, and I have a frequency of 1. So everything on this one was 1, which gives me a period of 2 pi divided by 1, and that would be just 2 pi. So if I were to start with this, I have to think my midline isn't 0 now, it's at 1. So I'm starting on the midline, I'm going up 1, I'm going back down to the midline, I'm going down 1, I'm going back. So when I draw now the second graph, we can clearly see that there is one solution, and that would be at 90 degrees. And hopefully you were able to follow that one. Let's take a look at number 8. Now, number 8 has a male figure skater and a female figure skater. The male is given by 3 sine of 1/2 x, and the female is given by -2 cosine of x. Now, this -2 is very significant because cosine of 0 is 1, but now I'm multiplying by -2. That tells me that my amplitude for this one, I'm going to do the pink one first. My amplitude is -2, is +2 rather, but because of the negative, I am going to start down here at -2. The next thing it tells me is that I have a frequency of 1, which gives me a period of 2 pi. But the domain they told me I had to use was 0 to 4 pi. That means I am going to have a full cosine curve, which begins at -2, is going to end at -2. Halfway in between is going to be a 2, and then halfway in between those are my zeros. And this is going to happen 2 times between 0 and 4 pi. So this one is going to look like this. So the next one, the male figure skater, he had an amplitude of 3. He has a frequency of 1/2, which means between 0 and 2 pi, I'm only going to see half this sine curve. That's why I needed to go out to 4 pi, because if I find the period, 2 pi divided by the frequency, I get 4 pi. So sine starts on the midpoint, on the midline, which now is 0 because there's no shift. Its highest point is 3, and then it's at 0. Its lowest point will be at -3, and then back to 0. So let's take a look. This is the male figure skater. He's making a sine curve. And if you think about it, this is the first place he would pick up the girl and spin her around, and this is where he would be putting her down. So they intersect 2 times. So the answer to this now would be 2 times. Now, you always want to check to see if you're doing it right. So this is when your calculator would definitely help you out. If we take out our calculator, again, let's make sure that we are in radian mode. So if I look here, I am in radian mode, and now my window has to change because my window went from 0 to 4 pi. And I basically counted in 90-degree increments, which would be pi over 2. And my y minimum was -3, so I'll just go to -4. My y maximum, I'll go to +4, and I'm going to count by 1. So now I had to reset this whole window. So now the male was 3 sine of 1/2 x, and the female was -2 cosine of x. And if I hit graph, notice you get that one big male sine curve, and we get the 2 for the female curve, and we get the 2 intersection points. So it should work out perfectly for you. Always check on the calculator if you can. And finally, before we leave, we have number 10. Now, number 10 is talking about the formula for a musical note. So here's the formula. Then they give us this musical note here with the formula filled in. Now, what we see with this is that 2 pi q and there's the time, which would be the x on a graph. And here, there's the time, that would be the x on the graph. But I now have 524 pi. So if I want to solve for Q, this is what they were looking for. Did you realize that this was the frequency and this was the frequency? And if you did, you divided both sides by 2 pi. And the pi's cancel. So the pi's cancel, and they cancel. The 2's cancel over here, and 524 divided by 2, 262. So I hope that you could do the odd yourself. Again, I will post my answers. Let me know if there's any questions. Good luck. Good luck.